Hey Math One, this is Mr. Roberts at Shasta High, and these are the 8 problems that were passed out today during Math Monkey, and I just wanted to record this just in case um, you weren't able to figure this out with your group and you have questions. So in the first one, this is clearly an example of the technique we've called fraction busters, and if I look at it, the very first term has a factor of 3 and it has a factor of x. The next term, the next 2 terms have factors of 5. So there's a 5. I'm going to need a factor of 5. This one, the 15, is 3 times 5. So what's cool is because I have a factor of 3 and I have a factor of 5, the 15 is going to be taken care of. And then the next one has a 5 and an x. So if I look at it, when I build all these together, I think these are called, it's called the least common multiple. It's 15x. So it turns out 15x would be exactly the value that would eliminate all those fractions. So how do I do that again? Kind of do it by focusing on the individual divisors, looking at them, 3x, 5, 5, 15, and 5x. And if I multiply across, every single one of these terms gets multiplied by 15x, 15x over 1, all the fractions will go away. So what I'm going to do is, next to each one of these dots, I'm going to go ahead and place 15x, and then I'll simplify it. So my first step is going to look like this. I'll have a 15x times a 2 over 3x plus a 15x times 7 over 5 plus a 15x times 3 over 5, and that will equal 15x times 21 over 15 plus a 15 times x times 1 over 5x. So now that every single one of those terms have been multiplied by a 15x, I can simplify. So in this first instance, right, when I have 15x divided by 3x, that's 5. So this becomes 5 times this 2. So this whole thing just becomes the number 10. Right? 15x divided by 3x is 5. 5 times 2 is 10. The next one I've got this 15x divided by 5. 15x divided by 5 is 3x. And 3x times 7 is going to give me a plus 70, plus 21x, right? 15x divided by 5 is 3x, and 3x times 7 is going to give me a 21x. The next one, I've got 15x divided by 5, which is the number 3. X, right? 15x divided by 5 is 3x times another 3 is going to give me a plus 9x. On the other side, right, what does this equal? We've got 15 times x times 21 over the number 15. Well, the 15 over 15 is going to be 1, and that's going to leave me with a 21x. Okay. And the last thing I have is 15x over 5x times 3. 15x divided by 5x is 3, and 3 times 1 is going to be plus 3. So I just noticed that each one of these have a 21x on each side. So my first step is just going to be write this as 9, or 10 rather, plus 9x equals 3. I'm going to subtract 10 from both sides. So I get that 9x is negative 7. And then for my final step, I'm just going to take and say x is negative 7 divided by 9. So I'm pretty confident in that answer, but certainly if time allows, I would want to double check that. So let me grab my calculator. And with the calculator, I'm going to go ahead and evaluate this by, first of all, storing the number 7/9 in for x. So if I zoom out here, I'm just going to on my calculator say negative 7 over 9, and I pressed enter. So that's the value, and I'm now going to store that in the variable x. So if I hit clear right now and I say I ask my calculator, what's x? It's going to say it's -7/9. Okay, so now that I know that I've stored what I think is my answer in the calculator, I'm just going to verify that both the left side and the right-hand side are the same. Because if this is authentically the answer, when I look at this side, right, I'm going to get the exact same number as when I evaluate the other side. So let's go ahead and start with this. The left-hand side is going to be 2 over, and I just type 3x, leave the fraction, plus 7/5. Oh, no, not that. Plus 7/5, 7 fraction key fifths, leave the fraction, and then plus 3/5. That's fun, plus 3/5. So what I get on this left-hand side is 8/7, right? 8/7. If the other side is also 8/7, then this really is our solution. But let's check the other side. The other side is 21/15. And to that, I'm going to add 1 and 1 over 5x. When I do that, I get 8/7. So because -7/8, right, -7/9 rather, made both sides of this equal to positive 8/7, this is the solution to the equation. All right, let's take a look at our next question. This next one involves this idea of looking inside. And what I really want to know is I want to know what this value inside the square root is, right? So first of all, those aren't just parentheses, right? This problem is trapped inside. It's trapped inside the radical symbol. It's trapped in this inside the square root. So before I can try to figure out what that is, I need to get the square root portion of this equation alone, right? So I want to get this entire square root thing by itself. And to get that alone, what I'm going to do is on both sides, I'm going to add 12 and then divide by 3, right? So you can imagine this was just an equation like 3 times a minus 12 equals 6. That's what I'm solving right now. So I'm going to solve by adding 12 to both sides. So I get 3 times the square root of 5x plus 7 has to equal the number 18. How did I do that? 6. What I just did was I just added 12 to both sides of that equation, right? So now that I've added 12 to each side, the next thing is, okay, I still don't have the square root portion alone. I don't have this green box alone. So I'm going to divide by 3. If I divide both sides by 3, this equation becomes the square root of 5x plus 7 equals 18 divided by 3 is the number 6. So at this point, on one side I have the square root of something. On the other side I have a 6. And I'm just asking myself, what do I take the square root of in order to get an answer like 6? I'm looking inside. Well, it turns out the thing inside the square root would have to be the number 36, right? The square root of 36 is 6. So if this box, right, if this was the number 36, I'd get the correct value of x. So now that I know the thing inside has to be 36, and if you don't know that, look, here's a secret. If you just square this value, if you square that, you get 36. But what I know is that 5x plus 7 has to be the number 36. Okay. Subtract 7 from both sides. I get that 5x has to be 29. And then divide both sides by 5, and I get that x has to be 29 over 5. So I think 29/5 is a solution to the original equation. And I'm going to check it. Turns out I'm not going to check it with my calculator because this is pretty straightforward. So if I put 29/5 in here, right, if I think this is 29, if that's 29 over 5, 29/5 times 5 gives me just plain old 29. And 29 plus 7 gives me 36. And the square root of 36 equals 6. So what this becomes is 3 times the square root of 36, which is 6, minus 12. 3 times 6 is the number 18, and 18 minus 12 is 6. So I can see that when I put in my answer, 29/5 into the left-hand side, it makes both sides of this 6, right? The left-hand side becomes 6, and the right-hand side was already 6. So my answer there is x is 29/5. We have time for just 2 more here. This next one, I was real honest. The very first time we started looking at questions like this, I said, I cannot ask you questions like this unless it's possible for us to rewrite the bases so that they're the same. The fact that one of the bases is 7 is a huge clue. And the fact that this is not a fraction means we're going to be looking at more powers of 7. So I know what 7 to the first is, right? It is 7. I know what 7 squared is, right? That's the number 49. And if I take and multiply that by one more 7, let me grab my calculator. I'm pretty sure, oops, where'd that calculator? No, there's the calculator. You can see it, but I can't see it. There it is. If I take this calculator and I take 7, just put 7 on the stack, right? 7 times another 7, that's 7 squared. That's 7 to the third, right? 7 to the third is 343. And on this calculator, if I pressed it again, it gives me 2,401. So I can keep getting more and more powers of 7 just by doing this. But I know the important thing, that 7 to the third is 343. What that lets me do is rewrite this side of the equation as 7 to the third. Okay, what is that? That's just 343. So I've got 343 raised to the power of 2x plus 5. And if I take a power and raise that to a power, the operation here is multiplication. So I'm going to multiply this 3 times the 2x plus 5. And this side of the equation becomes 7. Oops, let me just grab the black pen. It becomes 7 to the 6 times x plus 15. And on the other side, right, I'll just rewrite it. It was 7 to the 2x minus 1. So at this point, because both of the bases are 7, all I need to do is set those two exponents equal to each other and solve for x, right? Because 7 to the same power would make these truly equal. I just need to make this power and this power the same. So I just say, hey, 2x minus 1 has to be the same as 6x plus 15. Therefore, negative 1 has to be 4x plus 15. Therefore, it would be negative 16 is 4x. Therefore, it looks like x is going to be negative 16 divided by 4, which means x is the number negative 4. So I think I know what x is. X should be negative 4, right? But I'm going to check that against the original problem. So again, I go back to the calculator, clear it, and I'm just going to store, I'm going to store x this time. So I'm going to go negative 4. I want to store that in x. So this calculator now believes that x is negative 4, right? So on one side, I've got 7. I'm going to raise that to the 2x minus 1 power. And it gives me 7 to the 2x minus 1 power. It gives me this, a very tiny number. On the other side, I'm going to take 343 and I'm going to raise that to the 2x plus 5 power. So 343 raised to the 2x plus 5 power gives me the very same tiny, tiny number. So what that tells me is that x really does have to equal negative 4. So we have the solution there as well. The last problem we have is this one, and I'm going to say this is a great candidate for the idea of rewriting. So I'm going to begin by rewriting by just considering this, right? I'm squaring x minus 5. Right? Whenever I see that I'm squaring something, I actually like to write that out. So I've got an x minus 5 times another x minus 5. You might want to use an area model, right? So there's an x, there's a negative 5, there's an x, there's a negative 5. This is x squared. This is minus 5x. This would also be minus 5x. and this is 25. So when I square x minus 5, I get x squared minus 10x plus the number 25. And then if I bring down the rest of this equation, right, this side is plus 4x minus x squared. And on the other side, if I use the distributive property, this becomes 5x and then plus 5. I can see on this side there is a plus x squared, and right here there's a minus x squared. They're both on the same side, but because their signs are opposite, they cancel each other out. The other thing I have is there's a negative 10x and a positive 4x. So I think the left side is going to become minus 6x plus 25. And on the other side, that equals 5x plus 5. I'm going to add 6x to each side, so I get that 25 is 11x plus 5. Therefore, if I take away, oops, be careful, take away 5x from both sides, I get that 20 is 11x. Therefore, I think x is 20 over 11. I'm not sure about that. Probably I should check it, but the bell did ring. And I'm kind of out of time. So, hey, don't trust this answer. You didn't see me check this. I didn't check this. So maybe first is just check this and see if it's correct. And if it's not correct, a really cool thing to do is try to figure out where an error was made if the answer is not indeed 20 over 11. All right, so that's those first 4 questions from Primetime Monkey today. I hope you found this helpful. Good luck tonight. I'll see you tomorrow in class.